Hello everyone, welcome back, and in this video we will be talking about the AND before OR instruction. So basically the AND before OR instruction is represented by the letter O with no address passed to it, so it does not take an address in front of it. And the reason for that is that it's actually used to combine the result from AND blocks. In order to understand that, let's look at this diagram. Basically here we have two AND blocks, each of them having two inputs. And the result from these two AND blocks is then passed to an OR operation, and our final result is taken from there. So basically our instruction does what this OR block does. It just combines the result from AND blocks. And while on this diagram only one OR block is required, in our code we use multiple instances of this O instruction in order to do this functionality shown in that diagram. So let's take a look at our example code first. In our example, we have three AND blocks, with this being the first one, this being the second one, and this being the final one. And the result of each of them are combined. The results of each of them, of this block, mainly this block and this block, are combined using these OR instructions. And two instances were used here for our combination. Now let's see how the OR block actually, how the OR instruction actually works, and how it actually affects the status word register. For starters, as we said, our OR instruction does not have an address in front of it. So what will be reflected in the status bit? Previously we said that what is reflected in the status bit is usually the content of the address that is in front of the instruction. However, here we don't have an address passed to the instruction. So we have a rule that says that any instruction that does not have an address passed to it will reflect 1 in the status bit. So this OR instruction will reflect 1 always in the status bit, and the second OR instruction will also reflect 1 in the status bit. Now, before we see how this OR instruction affects the status word register and how it actually combines the logic of these AND operations, we need to first look back at our diagram. So in our diagram, if any of these AND blocks is fulfilled, or if any of them does output 1 on its output, then basically the result of the next AND blocks is not relevant to the actual result or the final result of this OR operation. So let's say that our OR operation is being evaluated, and our first AND block did output 1, then we will need to ignore the result of the second AND block. But if the first AND block result was 0, then the result of the coming AND blocks is relevant to the final result of this OR block. And therefore, let's take a look at how this actually happens. So basically, for all our use cases, our OR instruction or our AND before OR instruction will never come as a first instruction. However, if we place it as a first instruction, our code will actually work fine, but it will not do anything, as we will see later. But let's assume for now that our first check bit is 1. That means that our and before or instruction did not come first in our entire logic block. So let's see what it actually means. Basically, this is our entire logic block before the assignment instruction, and our OR instruction does have to come in the middle of our code. As we said previously, every AND instruction sets the first check bit to 1 after its execution. So before each of these OR instructions, or before each of these and before OR instructions, we will actually find that the first check bit was always 1. And now we have reduced our cases to actually 2 relevant cases. The first case is that the RLO, which is the result from the previous AND operation that came before the OR instruction, is 0, or the other case if it was 1. So basically first, if it was 0, it means that the AND operation that came before the OR instruction was not fulfilled, and the result of that block is actually useless to the result of the entire OR block. So basically, we will set back, or our AND before OR instruction will set back the first check bit back to 0, and the OR bit will be also set to 0 as it previously was. So this OR bit was already 0, as we said previously. Now, if the RLO, or of the result of logic operation from this AND, was actually 1, this means that a fulfilled AND block was reached before the AND before OR instruction. What it will actually do is that it will set the first check bit to 1 and set the OR bit to 1. And this means that we will move to the final state, or the final case, for all the AND operations that come after that OR instruction. So basically, if we look back here at the basic AND operation, we had our final case when the first check bit was 1 and the OR bit was 1, and therefore, in that case, our AND block will keep the result of logic operation fixed. It will not change it based on the address that is passed to that AND instruction. Now let's take a look at our example. And in our example, we are now dealing with memory byte number 2. So let's put memory byte number 2 here. And let's assume that our second AND block, which is concerned with these 2 bits, is the one that is fulfilled. So these 2 addresses will have to be set to 1. So let's set 2.2 to 1 and 2.3 to 1. And let's follow through with this code. So the first AND instruction came. The first check bit before it was 0, so it deduced that it was the first instruction. But as the value of the address here is 0, as displayed in the status, the value in the RLO will be 0. Same for the second instruction. We'll find that the first check bit was 1, so it will combine 0 with the 0 passed here with an AND operation, and the result of logic operation after execution of the second instruction will also be 0. Now we come to the first instance of our AND before OR instruction. This instance will find that the first check bit before it was 1, but the result of logic operation before it was 0. And what that actually mean that our first AND block has not been fulfilled. So when our OR instruction came, it sees that the first check bit before it was 1. So it is not the first instruction, but the RLO before it, or the value of result of logic operation before it, was already 0. Therefore, no fulfilled and block was reached before this OR instruction, and hence it sets the first check bit back to 0, and the OR bit is actually kept at 0. And therefore, it is as if this first part of the code never happens. These first three statements are useless to our final result. And then this AND instruction comes, sees that the first check bit for it was 0, so it is as if this is the first instruction in our block. But this time, the value stored in that address is 1. It will be moved to the RLO after execution of that instruction. So RLO after this instruction is 1, and we come to the next AND operation. It finds that the first check bit before it was 1, so it will use the previous result of logic operation, combine it with the content of this current address, which is 1, 1 combined with an AND operation with 1 will yield 1 in the result of logic operation. So this second AND block is actually fulfilled because we have, after its execution, 1 stored in the result of logic operation bit. And now the second AND before OR instruction comes. And this instruction checks before it. It sees that the first check bit was 1, so previous result is relevant, and therefore it will check the result of logic operation from the previous instruction. As the result of logic operation was 1, what this instruction will actually do is that first it will keep the first check bit at 1. It will set the OR bit to 1, indicating that a fulfilled OR operation and block was reached before this AND before OR instruction, and therefore the coming code that comes next is not relevant to the result, and the RLO is actually fixed at 1. From now on, we need to fix our RLO at 1, as this will be our final result. Now the next AND instruction comes and sees that the first check bit was already 1. So previous logic came before it. But because the first check bit is 1 and the OR bit is 1, the result of logic operation after execution of this instruction is kept as it is and is not affected with the address that is passed to this AND instruction. The same also applies for the next AND instruction. So basically, when it comes, it sees that the first check bit was 1. Previously, the OR bit was 1, and therefore keeps them as they are and keeps the RLO as it was. And then we come finally to our assignment instruction. It will set the first check bit back to 0, and it will set the OR bit also back to 0. The result of logic operation is then taken and moved to the content, to the address M2.7 as seen here and as reflected by the status bit. And this is our entire logic block. So basically, only one block needs to be fulfilled for our result to be 1. Before that fulfilled block, any result is relevant, as the first instruction that comes after an unfulfilled AND block will always be dealt with as a first instruction. And a fulfilled AND block will actually fix the content of the RLO, which is a result of logic operation, will also fix the content of the OR bit and the first check bit until we reach the assignment instruction. So these three bits will actually be fixed if we reach a fulfilled AND instruction. The first check bit, the result of logic operation, and the OR bit. And this is how the AND before OR operation is used to combine AND blocks. Let's actually modify this example a little. So here, let's just add another OR instruction here and download this code. And we will actually keep this AND instruction to be our fulfilled instruction. So for this force instruction that we added in the middle, when this instruction came, it found that the first check bit before it was 1. So basically, logic from previous blocks is to be used, but it also found that the result of logic operation was 1. So as we said before, it will set the first check bit to 1, which is already here. It is already set to 1. And it will set the OR bit to 1, which was already set to 1 by the first OR instruction that came after the fulfilled AND block, so it will be kept at 1. So this actually tells you how this AND before OR operation is used to combine these AND blocks. There is actually another way of combining these two AND blocks, but it requires use of the nesting stack. So doing it or doing the combination this way is actually faster than using the nesting stack. Normally, we don't use the nesting stack for combining AND operations, but it can also be used. It will yield the same result, although it will be slower in terms of execution. Now, another interesting example would be if we actually replace one of these instructions with a normal OR instruction. So let's say the ORing is between AND blocks and a normal address. So let's see how that actually affects our code. Basically, let's replace this AND instruction and the previous AND before OR instruction with a normal OR instruction and see how this affects our code. So let's download this code and monitor it. And remember, in our example, this was our fulfilled AND block. So basically, the result of logic operation after execution of that block was actually 1. And when this OR instruction comes, it actually finds that the result of logic operation before it was already 1. First, it will find that the first check bit before it was already 1, so previous logic will need to be combined with the current address. So the previous RLO, which was 1, will be combined with the value of the current address, which is 0, and will yield 1 in the result of logic operation. And then the next AND before OR instruction comes and finds that the first check bit before it was 1 and finds that the RLO was 1. So what it will actually do, it will write 1 in the first check bit and write 1 in the OR bit, indicating fulfillment of the logic that came before it. So the result here will actually not change. The final result will actually not change. And this is how this OR instruction behaves when combined with this AND before OR instruction. Now let's change the values of these addresses to have a better look at what's happening here. So let's change these two addresses back to 0. So 2 and 3 are actually changed to back to 0. And let's change M2.4, which is in front of this normal OR instruction, to 1. So 2.4 will be set to 1, and we will see what will happen in that case. So for the first OR instruction, this has not been fulfilled. So basically, it will set the first check bit to 0, and the OR bit is actually staying at 0 with the RLO still being 0. And when we come to this OR instruction, it will actually find that the first check bit before it was 1, so it will actually need to use the result of logic operation from the previous instruction. So 0 will be combined with 1 with a normal OR instruction, and the result of logic operation will be 1. But the next and before OR operation, when it comes, it will find that the result, the first check bit before it was 1, but also the result of logic operation before it was 1, and therefore it will deduce that fulfillment has been reached before this instruction was called, and therefore the OR bit will be set to 1, and the result of logic operation will then be fixed throughout any code lines that come before it, and the final result remains actually at 1. And this is what we have to say about this modification. Let's finally put an and before OR instruction at the beginning of our code and see what will happen. So let's add one here. Save this code, download it, and monitor it. And as you can see here, this first and before OR instruction, when it came, it found that the first check bit before it was 0. So what it actually did is that it did nothing. As you can see, the one reflected here is actually the status. As we said before, the OR instruction will always reflect 1 in the status bit, but nothing actually happened to any of these bits. But remember, putting an and before OR instruction here is actually useless. You're actually costing yourself an extra line of code, which basically takes space in the memory of the PLC, and therefore you are not advised to put any useless instructions. In fact, you should try to save as much code lines as possible. So this case is useless and is never used. So let's actually remove it. And that's it. That's actually what we have to say about this example. So to summarize what we are saying, basically the OR bit normally, the and before OR instruction, when it comes normally, the first check bit before it will always be 1, as it will not be coming as a first instruction. And if fulfillment has been reached before it, then the RLO will remain at 1 for any code that comes after it, and until we reach the assignment instruction. And if no fulfillment has been reached, then the entire code block before it is actually ignored, and it is as if the instruction that comes after it is the first instruction. So that's basically the summary of what we have said through these examples. Now that we are done talking about the and before or instruction, we have finished our talk about basic logic operations. Remember that basic logic operations only work with the status word register, as we previously said. And from the next video, we will be looking at nesting logic operations that use the help or require the help of the nesting stack to evaluate the result of the logic block. So thank you for watching. Please like and subscribe to the channel.